test for equality of two mean. Suppose two independent large samples of size n1 and n2 are drawn from two populations with mean mu1 and mu2. The standard deviation sigma 1 and sigma 2. We want to test whether the mean are equal. The procedure for testing H0, the null hypothesis mu1 equal to mu2. The alternative hypothesis mu1 not equal to mu2. Two-tail test. If the null hypothesis is true, then the sampling distribution of x1 bar minus x2 bar has mean for order of mu1 minus mu2 equal to 0. It is sampling x1 bar minus x2 bar equal to square of sigma 1 squared by n1 plus sigma 2 squared by n2. So is it equal to x1 bar minus x2 bar divided by of x1 bar minus x2 bar is approximately normal. Approximately normal. Inference. If modulus of z is less than 1.96, H0 is accepted at 5% level. If modulus of z is greater than 1.96, H0 is rejected at 5% level. If modulus of z less than 2.58, H0 is accepted at 1% level. If modulus of z is greater than 2.58, H0 is rejected at 1% level. If the population standard deviation sigma 1 and sigma 2 are not known, then we can take S1, S2. The sample standard deviation is the best estimation of sigma 1 and sigma 2. The samples are large sample. An example. Random samples drawn from two places gave the following data. Relating to the height of male. Mean height inches and standard deviation of height and sample size. Part A and part B. Mean part A is 68.50, Part B 68.58. Standard deviation 2.5, here 3.0. Sample size 1200, 1500. Test at 5% level that the mean height is the same for males in two places. Solution: mean of the first sample x1 bar equal to 68.50, and standard deviation of the first sample 2.5. Sample size of the first sample 1200. Then mean of second sample x2 bar, that is 68.58, standard deviation 3, sample size 1500. The null hypothesis mu1 equal to mu2, that means mean height is the same in the two places. The alternative hypothesis, mu is not equal to mu2. Mu1 is not equal to mu2. Now the test statistics is z equal to x1 bar minus x2 bar divided by square root of s1 squared by n1 plus s2 squared by n2. That is equal to 68.5 minus 68.58 the whole divided by square root of 2.5 the whole power 2 by 1200 plus 3 squared by 1500. Use calculator. And this value is minus 0.08 divided by 0. That is square root of 0.00052 plus 0.006, that is 0.1058. That value is minus 0.76. So therefore modulus of z is 0.76. Conclusion: H0 is accepted at 5% level since the calculated value of z is less than the table value of z. Hence, the mean height is the same for two places. Next example. The previous problem, two means and two standard deviation given. This problem, the mean of two samples 1000 and 2000 members are respectively 67.5 and 68 inches. Can they regarded as drawn from the same with standard deviation 2.5 inches. But the previous problem, 2 standard deviation given. So in this case, a single standard deviation. Sample 1, x1 bar 67.5. Sample 2, x2 bar 68 inches. And n1 here 1000, here n2 2000. But standard deviation sigma 2.5. Population standard deviation sigma is 2.5. The two given samples are large sample. So H0 null hypothesis mu1 equal to mu2. That means the sample belongs to same population. Mu1 not equal to mu2. The test is set equal to x1 bar minus x2 bar whole divided by sigma will be taking outside, so 1 by n1 plus 1 by n2. That is equal to 67.5 minus 68 divided by sigma is 2.5, 1 by 1000 plus 1 by 2000. So use calculator. Just the value of z is minus 5.15. So we are going to take the modulus of z is 5.15. The table value of z at 1% level of significance 2.58. At 1% level is 2.58. So conclusion, the calculated value of z greater than the table value of therefore the null hypothesis is rejected at 1% level. So the two samples cannot be regarded as belonging to the same population. So example 1, two different standard deviation given. Example 2, a single standard deviation given. Another one example. The following table gives the data on the hardness of wood stove, hardness of wood stored outside and inside the room. sample size, mean, but here sum of squares given, squares of deviation from the mean. Okay, outside, inside. Sample size outside 40, here 110. Then mean 117, 132. Sum of squares of deviation from the mean 8655, 27244. Test whether the hardness is affected by weathering. Here sample size n1 equal to 40, n2 equal to 110, and x1 bar equal to 117, x2 bar that is equal to 132. But sum of squares s1 squared equal to summation of x minus x bar the whole square divided by n1, that is 655 by 40, that is 216.38. Then s2 squared, sum of squares is 27244 by 110, use calculator, 247.73. Now we can use the second type of the null hypothesis mu1 equal to mu2. Hardness is not affected. Hardness is not affected by weathering. The alternative hypothesis mu1 is not equal to mu2. Z equal to x1 bar minus x2 bar divided by square root of s1 squared by n1 plus s2 squared by n2. That is equal to 117 minus 132 divided by square root of 216.38 by 40 plus 247.73 by 110. Use calculator, that value is square root of 5.41 plus 2.25, that is equal to 5.42. Conclusion: H0 is rejected at even 1% level, since calculated value of Z is greater than the table value. Therefore, the hardness is affected by weathering.